Ports are strategic infrastructures where digitalization tools and technologies could support port environmental sustainability. There is a commitment towards a lower carbon footprint through the achievement of green, viable, attractive, and efficient zero emissions in ports. Green Seaports, co-funded by the European Commission through the Connecting Europe Facility program, aims to pilot the use of sensors, big data platforms, business intelligence tools, and artificial intelligence modeling to reduce the impact of port operations on their cities, monitor emissions from ports and vessels, increase the efficiency of port operations and optimize handling of cargo in core ports, facilitate access and egress of cargo in and out of core ports. The first phase includes the installation of different sensor networks at the participant ports, which transmit environmental data to a Port Environmental Performance (PEP) IT platform. Moving to a second phase, 6 case studies come into action through predictive analyses of ports' environmental performance. Big data modeling and advanced predictive analytics support the process and make the path for the development of platforms and mobile applications which allow real-time access to the main port environmental parameters and short-term predictions for both internal and external users. The first business case seeks to decrease port traffic congestion through the prediction of the date and time of entry and departure of trucks. This allows port managers to take necessary measures to reduce traffic congestion and decrease CO2 emissions generated by trucks at gates. The second pilot case study aims to improve maritime accessibility to ports. The PEP platform integrates different platforms, sensor networks, and sources of information to predict the closure of the Port of Venice due to tide, wind, and fog, and consequently to optimize date and time of entry and departure of ships using predictive analytics and big data tools. Business cases 3 and 4 aim to improve air quality and noise in both the Greek port of Piraeus and the port of Valencia. With the piloted technologies, port managers are able to know the exact quantity of emissions generated by a particular ship, predict air quality levels in a near future, and estimate how much noise is generated by ships calling at specific berths at the port and due to the loading and unloading operations of certain vessels. The fifth case study is based on forecasting ship-to-shore crane productivity in the German ports of Bremerhaven and Wilhelmshaven. Factors affecting productivity such as wave agitation, currents, and wind have been estimated, resulting in a reduction of the length of the ship's stay in the port and its emissions. The last case study oversees measuring real-time emissions along a multimodal transport chain. Shippers are able to compare different multimodal transport chains, therefore, they can select those that provide greater efficiency and lower environmental impact.